Okay, so welcome to 2014 Paper 2 Audio Levels Label Cert. This is question 5. Okay, so it's a tricky question from first glances, and it's worth 5 marks for part A. Part B 1 and 2 then are split into 10 and 5 marks. Let's get stuck into part A here. The square ABCD has an area of 81 centimeters squared. Find the length of AD. Now, it's a square. Now my image here is a bit stretched, so it doesn't actually look like a square, but in the actual exam paper it does look more realistic. Just be aware of that. If it's off-putting here, it's just that I've stretched this to make it fill the full screen. I'm going to go to the answers that are typed out. So the area of a square is the same thing as length by breadth, but since the length and breadth are the same thing in a square, you can equally express it as length by length, and length by length is the same thing as length squared. Okay, so that should be okay. I often learn off this. When I see an area of a square, I write the formula as this, but that's just from practice. Okay, so that develops me the formula, the equation L squared equals 81. Okay, now if I want to solve that, bring the square across to the equal becomes a square root. So the L is equal to the square of 81, which is 9. And I put in my centimeters to show my units. 5 marks. Okay, so part B then, there's 2 parts here, 1 and 2. A sector of a circle, okay, center B. So you have here, again now remember it's still stretched. So those A, B and C and A and B are the same length, and they're both 9. We've just worked it out. So we'll have included that on the diagram. Okay, that's probably your attempt. So a sector of a circle, center B and radius BC, is drawn inside ABCD, drawn inside the square, and is shown there by the shaded region. Okay. Find the area of the sector correct to 1 decimal place. If you look at it, okay, that's a quarter of a circle. Okay, so if you find the area of a circle, what's a quarter of that is your answer. So we've done here. So you have a circle, the formula is in your mass tables. Okay, so it's pi r squared. I'm putting the formula in here just so before I do any work, so it's all clear. I'm looking for a quarter of the circle. So it's a quarter times the area, and reflect that on both sides. That's the same thing as pi r squared over 4, or you can express it different ways, but ultimately it's the same thing. I'm going to leave it as it is for the calculator. So I'm putting in the information I have, which is the radius, and I have pi stored in the calculator. I could use an approximation, 22/7. I could use the approximation 3.14, but I would suggest you always use the calculator, the pi button on the calculator, because that's the answer that the examiners are looking for. And what we are looking for the answer given by 22/7, or 3.14, it's not the one you're really looking for. So you're making life a little bit harder on the examiner. For no real reason, because those figures 22/7 or 3.14 are approximations of pi. Your answer will be less accurate than if you use the pi button on the calculator, so that is the suggested one to use. Anyway, throwing all that in the calculator, quarter times pi times 9 times 9 comes out from my calculator as 63.6 centimeters squared. I probably already rounded it here for the answer. Whatever answer you get in the calculator, just round it back to 1 decimal place. It's a mark lost if you don't. Put in the units, okay, so centimeters, and it is squared units, so centimeters squared. And they're squared units because it's an area question. Okay, part B, part 1 done. Happy 10 marks. Now, a second sector of a circle is drawn center D, so your center is here, okay, and the radius length dA. Remember, dA is still 9. Find the area of the shaded region, the overlap of the two sectors correct to 1 decimal place. Okay, so the full area of the square, the box, okay, is 81. You're taking away the 63.6, so you're trying to find this unshaded area here. No, it's the same area here. Okay. You're then going, well, that's 17.4, but in the actual question you're doing, you have 2 of them. Okay, so it's the second one because the other arc creates this ellipse shape. So it's 2 times 17.4 gives you 24.8. Okay. Now, you've now found the area of the 2 unshaded regions. You want to actually find the area of the shaded region, okay, which is this bit in the middle, that I'm highlighting now at the moment. So you're going to take the 81, which is the entire box, take away the 2 little parts on your side, which is 34.8, you're left with 46.2. And again, that's unit squared. Now, to be frank here, this kind of question, some people, no problem. Other people, it's just so much going on. They might have a fair bit of trouble with part 2 there, okay? And if that's the case, you're looking then at least going for the attempt, okay? So any relevant work will get you that, okay? So just try something, okay? And then hopefully that something will be enough. I would suggest, using the area of the 81, use of that, take anything away from it, would probably get you the attempt, okay? Just depends on the year and how they adjudicate it, okay? Now, that's part B, question 5, part B. So move on to question 5, part C. Now, this gave me an awful lot of trouble, this particular question. I'll be straight up and honest with you. Let's read it and see where the trouble comes from. The point P is on the arc of the sector DAC is shown. Okay, so you have your arc here. Okay, and your point P on it. The triangle APC, so the shaded triangle here, APC, is isosceles. Now, that means that this length here and this length here are equal. Now, it won't need it, but that would mean the angles here and the angles here are equal. Okay. Find the area of the triangle APC correct to 1 decimal place. So, it's an area of a triangle. We're not dealing with angles here, so it's going to be a half base by height. The question then is, how do I get the base? Okay. And how do I get this height here? And that here lies the problem. Okay. So, getting the base is easy. That's just the diagonal. So, if you're taking this triangle here, okay, and you're going, right, what's the hypotenuse of that triangle I just shaded in? Remembering this is 9 by 9. Okay. So what's the answer because I've done out? That's here. The length of AC is equal to AD squared plus DC squared. Now AD and DC are both 9. So the AC squared equals 9 squared plus 9 squared, which is the same thing as 162. Bring the square across, you end up with the length of AC is equal to the square root of 162. That's the length of that diagonal. So, job done. Okay, attempt there. Now, unfortunately with this question, okay, this is a hit or miss question. So, it's either right or wrong. Okay, if you don't get the full correct answer, you got nothing. No matter how much work and effort you put in. So, you won't know that doing the exam. So, like everything else, you still should be aiming to get the attempt. Even though in this case, that's not of any good use to you. The second we need to know is this length PO, the perpendicular height. If I do know that, then it's just a half base by perpendicular height. Job done. Now, this is the bit I don't particularly fully get, okay? What they're doing is taking away I should have supposed to clarify this first. The length of AC is the same thing as the square root of 162, which is the same thing as 9 times square root of 2. And the calculator would probably have simplified that for you, okay? But we could go through the steps of simplification there, but I'm not going to in this particular video. So the 9 is the length of the sides, okay? Now it would also be the length of this distance here. No, it wouldn't be. Okay, so basically taking the 9, okay, point here. Okay, that's reflected here as well, and here as well, and here as well. They all coalesce to the center, which is O. So you're taking half the diagonal away from it. Okay, so it's 9, take away half of this diagonal length. Now, to be honest, I don't fully get what they're doing there. I've looked up books and I've looked up different things, and I still don't get it. I think it's based on Pythagoras' theorem. It's not, that's the theorem itself, it's like more like an axiom. It's just not one I'm familiar with, and I've spent a long time trying to figure out what it is. I think I might be having a brain freeze on it. I've came back at it multiple times and still have the same problem. If I ever get a chance to really reflect on it and figure out exactly what's going on, I might replace this video. But for the time being, I would not have gotten this question in the exam. I would have gotten enough for an attempt, I'm sure, but again, that's no use to you when you see the actual mark scheme for that year. But let's just assume that this is true. Okay, it's in the mark, taken it from the market scheme is how I actually know what the answer is. Now, what I've done is they've just changed the orientation here just to make it more useful. Okay, so I'm basically dividing across by 2. Okay, so 18 over 2 is the same thing as 9. Minus 9 times square root of 2 over 2 is the same thing as what's written there. So I've just written it slightly differently. You don't really have to. I could use that whole chunk in the calculator. It just makes programming a little bit harder. So the area of APC, the shaded triangle here, is equal to a half base times height. Okay, so a half. Now the base is 9 square root of 2. Okay, that's the AC there. We calculate that using Pythagoras. The PO here, the length of PO is 18. This is 18 minus 9 square root of 2 all divided by 2. Which again, so it's what I'm not fully understanding how the reasoning behind that. But I put it to the calculator, I end up with 16.8 centimeters squared. That's rounded to 1 decimal place. So sorry about the confusion about that question, but I'm confused because I'm confused. And it's just something that I'm missing in my own education, or again, like a brain freeze. And when I've ever had these brain freezes before, you come back and look at it later and just go, oh wait, that was obvious. But in the time of an exam, it's going to happen. You're going to have brain freezes, you're going to have things, you know it, you just can't remember what the hell it actually is. But that's the nature of these things. And if it happens only once or twice, that's just, you gotta own it. If it happens more than that, you're having a bad day. And the only way to get around that is, if you're having a bad day and every question seems like gobbledygook, just take the break, walk out, go have a toilet break, splash more in your face. When you come back in, sometimes the paper just looks completely different, and all those brain freezes are breaking up. They just go away. So, best luck, and I hope that doesn't happen to you. And that's question 5, 2014, and thank you.